So we know that Chapter 8 is all about rational expressions, and Section 8.4 is on multiplying and dividing these rational expressions. Now when you hear the word rational, you should think of fraction, because a rational number is any number that can be made into a fraction. So that would mean that a rational expression would be an expression inside of a fraction, so the same kind of definition. And in simplified form, the numerator and denominator have no common factors. So you've canceled out all the common factors, that's simplified form. And you can only simplify when multiplication is involved. So if we have adding and subtracting, we can't really simplify, and I'll show you what I mean, unless every single term would have a common factor. So let's start with this example where we're simplifying the rational expression. This is a rational expression because it is an expression inside of a fraction. Our first step is we need to factor this because there's not something in every single term that we can cross out. You might think, well, we can maybe cancel out a 4 because there's a 4 here and here, but it doesn't work like that. You can only do that if it's all multiplication. If we have adding and subtracting, it has to be in every single term to cancel it out. So the first step is you want to factor this. So we're looking for factors of 12 that subtract to give us 4, because this is a quadratic. So factors of 12 that subtract to give us 4 would be 6 and 2. And we have a minus 6 because we want to get negative 4. And on the bottom, this is the difference of two squares. So it'd be x plus 2, x minus 2. So now that we have simply multiplication, you see how this binomial is times this binomial? Same thing on the bottom, it's all multiplication. So I can cross out these x plus 2's, and this would be your final answer. That's completely simplified. Same thing's going to happen here. And if you think about what we're doing, we're actually dividing these two expressions. The fraction bar means divide, so really you're dividing this expression by this expression, and when you simplify, you're left with x minus 6 over x minus 2. Just something to think about. So if we do the same process here, we want factors of 6 that subtract to give us 5, so that'd be 6 and 1, and we want a negative 5, so we need a negative 6 plus 1, because that gives negative 5. And on the bottom, this is the difference of two squares again. So we have x plus 1, x minus 1. And you see that your x plus 1's cancel. And you're left with x minus 6 over x minus 1. So let's move on to something that looks a little bit different. Now we're dealing with monomials, not binomials. Monomials meaning just one term. This right here is just one term, even though there's an x and a y. Since it's all multiplication, this is just one term. Same here, this is one big term. You could have 20 letters on here, and it would still be one term. This is pretty simple because we just cancel out on top and bottom common factors. I love doing this because you cancel out stuff and then you're left with a little tiny answer. It's really fun. So, as long as something is on bottom or on top, you can cancel. You can go crossways or straight up and down, it doesn't matter, as long as something's on bottom and on top. So here I'm going to cross out this 5 and 10 and simplify it, because 5 goes into 10 twice, so that 10 becomes a 2. And here on the 2 and 6, 2 goes into 6 3 times, so this 6 becomes a 3. Then look at our x's here. Here I have an x on the bottom, you have 2 on the top, so one of those cancels out. And on the bottom it looks like I have, altogether on the bottom, we have a y cubed and a y, so that really that's y to the 4th, there's 4 y's on the bottom. And on the top there's a y here and 2 of them here, so there's 3 on the top. So if there's 3 on top and 4 on bottom, that means there's going to be 1 left in the bottom. So all 3 on the top go away, and you cancel 3 in the bottom and you're left with 1. So then you just multiply what we have left. On the top we have a 3 times 1. And we have an x and 3 x's over here, so that's x to the 4th, and all of our y's canceled. And on the bottom I have 2 times 1, so just 2. All my x's are gone, and I just have 1 y. So that would be completely simplified. Let's try another one. So here, do you see you can cancel this 3 out with the 12 or the 9? Doesn't matter which one you want to do. I'm going to cancel out the 3 and the 12. So 3 goes into 12 4 times, and 9 goes into 27 3 times. Now let's look at our letters. On bottom I have an x squared, so I have 2 x's down here. And in the top, it looks like I have 7 of them. So I'm going to cross out the 2 on the bottom and cross out 2 up top. So this x to the third, I cross out 2 of them, there's just 1 left. And then my y's, I have a third and squared, so there's 5 y's in the bottom. And it looks like there's 6 on top, because we have y to the 5th and y. So if we cross out all 5 of these, and 5 in top, then we can multiply. So we have 4 left, and the x's, I have an x here and x to the 4th, so that's x to the 5th. Because remember, when you multiply, you add exponents. And I also have a y left. And on bottom, it looks like I have a 3, and all of my x's and y's canceled. So this is completely simplified. Now, if you went to go multiply and you found out you had a y on the bottom, and you thought, oh, I can still cancel this out, that's okay. You could get to this step and cancel it out, and then write your new answer. That's not what happened in our case, but you can still do that. So now we're going to multiply rational expressions involving polynomials, so not just one term, but we're actually dealing with expressions here. Your first step is to factor anything that can be factored. So let's start over here. Look at maybe a common term you can factor out. You see in this top here, we could pull out a 3 and an x. And if we do that, we pulled out the 3x, we're left with 1, minus 27 divided by 3, we're left with 9. We had x cubed, we pull out 1x, we're left with x squared. On the bottom here, we have a leading coefficient other than 1, so we need to multiply the first and the last. And you're looking for factors of 3 that are going to give you -2, which would be -3 and 1. So we go to factor this, and you rewrite it, except rewrite the middle term as -3x plus 1x, because this equals -2. Group the first 2 and the last 2. Pull out your common factors. So here we can pull out a 3x, and we're left with x minus 1. And here you can't pull out anything, so you're still left with x minus 1, which is good, because your 2 factors are what you pulled out. And we pulled out a 3x, and a 1 is sitting right here. So your first factor is 3x plus 1, and the second one is x minus 1. So that goes in the bottom right here. Now let's move to the other side. Same thing's going to happen here. We have a leading coefficient other than 1. So we're looking for factors of 3 that give us -4. Which would be -3 and -1, because that adds to give us -4, and it multiplies to give us 3. So we rewrite this. Rewrite the middle term as -3x minus 1x. Group the first 2 and the last 2. Pull out what's in common. So we have x minus 1. Here we want to pull out the negative. So it becomes x minus 1. And the 2 factors are what you pulled out, which now is 3x minus 1 and x minus 1. So that goes on top over here. So it's a lot of factoring. And on bottom we have 3x, which that doesn't really factor, so that stays there. Now comes the fantastically fun part where you cancel out common terms. 3x and 3x goes away. X minus 1, x minus 1. Goes away. So if we write what we have left, something else actually happens. If you look at this right here, this is actually the difference of 2 squares, because 1 is a perfect square, 9 is a perfect square, x squared is a perfect square. So this actually factors into 1 plus or minus, and the 9x 3 squared gives us 9, so 3x and 3x. And you'll see that now we have 1 plus 3x. That's the same as 3x plus 1. They're just flipped around. It's the same thing. So those can cancel. So on top we have left 1 minus 3x and this 3x minus 1. And everything on bottom canceled. So this is your answer. The last example we're going to do has multiplying and dividing together. The first thing you want to do is if you see a division sign, the same thing as dividing is multiplying by the reciprocal. So let's rewrite this using the reciprocal. So we have x over x plus 5 times 3x minus 5. Change this to multiplication and flip your fraction. And now let's look to see what we can factor. This first fraction, nothing you can factor. The second one, you can't factor that. You can't factor x plus 5. You can factor this, because 9 is a perfect square. 25 is also a perfect square. There's subtraction. So that is the difference of two squares. So everything else stays the same. And if you need to, just for your own comfort, you can write this over 1. Don't have to. And this factors into the root of 9 is 3. So we have a 3x and a 3x. Plus, minus, the root of 25 is 5. Now you can cancel things out in common on top and bottom. You see we have an x plus 5 on the bottom and on the top. Those cancel. We have a 3x minus 5 on the bottom and on the top. Those cancel. So we have left on the top just this x. And on the bottom, you don't have to write the 1. We just have the 3x plus 5. So the only difference when we have multiplying and dividing, if you see a divide, right away change that to multiplication and flip your fraction. And then the process is the same from there. So lots of factoring in this section. So I want you to try this one. First step is to factor. You're going to be able to factor everything except the 4x. Everything else should factor, and you'll be able to cancel some things out.